Okay, so let's look at more steps. We just did 2, but what's going to happen when we go to 5? So look here, there's 5. So 1, 2, 3, 4, 5 different steps. So if you had to make a prediction about where you'd end up more, or even just once, I'm going to try this once. So where am I going to end up down here? Take a second, try to make a prediction, and let's see if you can get it. I have a little friend here who's going to walk the path for us. So he starts up at the top. Let's do this. Yellow. Red. Yellow. So how does it look? Do you think he's going to make it to your predicted spot? Red. And yellow. Did it match your prediction? Okay, so the question is, which one of these endpoints are going to come up more often than the other ones? Which one's going to win? So it's kind of hard to say on an individual try, like here, maybe this matched, maybe it didn't. What we could do is we could repeat the experiment a bunch of times like we did for the smaller case and then see what the tallies look like. Or, as we did in the other case, we looked at how many paths can you take to get down to a specific endpoint. So let's try that. If we start up here and we're thinking about this endpoint, well, we have to go from top to bottom. We can't go backwards. So there's only one way to get down here, right? Only one way. I'll put a 1 there. And maybe the other side is the same. Let's see. If we go to the yellow side, well, the only way you can do this is if you get yellow each flip. This is the only path that works. So there's 1. Let's try this one. Okay. Well, we could just travel down like we're going to that last endpoint and then take a detour here. So that's one way. We could start that way again, take an earlier detour. That's 2 ways. We could take an even earlier one, 3, 4, and 5. But there's no other ways to get there. So that's 5 ways. Let's go over to this side. So we could go through the process of counting this up the same way, but due to the symmetry here, I bet that it's 5. And if we look at it, 1, 2, 3, 4, 5. It is 5. Okay, so these ones in the middle, they look a little bit more complicated, don't they? There's lots of ways that we could end up at these dots. How do we count them? Well, let's go back up here and think of each dot and think of how many paths we could take to get to each dot. Well, this dot, we're starting from the top, there's only one way to get there. So I'm going to stick a 1 there. This one, same, just one way. This one, well, we can get to it that way, or we can go this way. So there's 2 ways. What about this one? Well, we can't go backwards. We have to just go from top to bottom. So there's only one way for that one. Same with this one. When we get down here then, how many ways can we get there? Okay, well, there's 1, there's 2, and there's 3. But you know, we could have saved ourselves some traveling here, and we could have just said, well, there's 2 ways to get here and 1 way to get here, so we could just add those up, and we get 3. That's going to work over here too. And then when we come down here, again, there's only one way to get here. We have to follow this red line. So instead of trying to find all the paths for this dot, we could just add up those like we did before. And what happens when we add 3 and 3? We get 6. And then over here we're 1 and then 4. See the pattern? Look here. 1, 1. We already have the 5, we already have the 5, that works out. And now these ones that we thought were challenging aren't so challenging anymore, because instead of having to find all the paths, all we have to do is add up the 4 and the 6. It's 10, right? Same here. So there's 4 ways to get to this dot, 6 ways to get to this dot. We want to know how many ways to get here. Well, we could go from here to here, from here to here. 4 ways to get there, 6 ways to get there, so there must be 10 ways to get down here. We add this one and this one. So now that we see this triangle actually has a special name. It's called Pascal's triangle. Look at the nice patterns that you're seeing here, the symmetry. This is telling you that these middle outcomes, these middle dots, are going to come up more often than the outside ones.